Welcome to EDU World Space.
Once again, welcome to a new problem. This time we have a thin sheet of ice. So we're given that um, there is a ball. So there is a ball being thrown in the positive direction with the velocity. The mass of the ball happens to be um, the mass of the ball is given as 0.600 kilograms. And then you have a person, you have someone standing. So you are the one who was standing on this surface, waiting for the ball with your hands. Okay, and your mass, we're gonna call your mass A. So let's just call it A, and you happen to be 70 kilogram in terms of mass. And so your friend throws a ball towards you and it's traveling at 10 meters per second. So that's considered the initial velocity um, of the ball. So VBI, okay, that's the initial velocity of the ball, happens to be 10.0 meters per second. That's what's given. That's the information that's given in part A. We want to find out what's going to happen in terms of the so once you catch the ball, what's going to be your velocity? So again, we're looking for kind of like some type of um, final velocity, which is a common velocity between you and the ball. If you catch the ball and you don't fall, we're looking for a final velocity. And then in part B, this time something different happens. Both you and the ball move in opposite directions. So you move towards the positive direction. So we want to find your final velocity that way. And then the ball moves in the negative direction. So we also want to find the final velocity of the ball in the negative direction. So pretty much that's what's given in the problem, and we'll go through different steps to see how to solve this problem. First thing we want to do is we want to compute what we call the initial momentum of the system. Okay, this is the initial momentum of the system. And that means we want to find out the momentum of the ball. The initial momentum of the ball is the mass of the ball times the initial velocity of the ball. And then also your initial momentum um, of yourself, that's your mass, times the uh, uh, times your initial velocity. Remember, the initial velocity in your case, as you can recall, happens to be what we're calling VAI, happens to be 0 meters per second. So you want to recall that. So that's the information that we're looking at. Also, we want to find the final momentum of the system. So we want to find the final momentum of the system, and that's combining the final momentum of the ball. So we have the ball's final momentum. It's going to be the mass of the ball times the final velocity, which is a common velocity. So we don't have any distinct velocity between the ball and you. So we're just calling that VF, V final. And also we are looking for your own final velocity, which is your mass times the velocity. So this is the information we're given. We're using law of conservation of momentum in the second page, law of conservation. Um, of momentum pretty much says that the final momentum of the system equals to the initial momentum of the system. The final momentum is the combination of these two. So, that's the final momentum of the ball's final momentum, plus your own final momentum, and that should equal, if you go back, you see the ball's initial momentum and your own initial momentum. So if we plug in the numbers for the finals, we get MB. We can get MB V final plus MA V final. This is equal to MB V B initial plus MA VA initial. Remember, this one is 0 because it's 0 meters per second. And our goal is to get the final, so we can pull that out and have MB plus MA equals to MB V B initial. And then we solve for the final velocity for both you and the ball by just moving stuff up, and that means dividing by well, you know what, I'm going to continue this right here, there's more space. Dividing by MB VBI all over MB plus MA. So that should give us the final velocity for you and the ball. We have 0.6 and 10, and then 10. So we have the mass of the ball is 0.6 kilograms. That's multiplied by the initial velocity of the ball, which is 10.0 meters per second, and then divided by the mass of the ball, which is 0.6 kilogram, 600 kilograms, plus your own mass, which is 70.0 kilograms. Always a good habit to leave your problem solving up until the final step, and that just means that we're gonna divide these numbers. See, the final solution will be in terms of velocity, because when the kilograms cancel out, you end up having velocity. So we have 0.6 times 10, and then divide by 0.6 plus 70, and that gives us the final velocity between you two. And so that velocity we're looking for ends up being 0.085 meters per second. In the next part of the problem, if you go back, the second part of the problem wanted us to do the same exact thing, but this time, the ball is bouncing off of you, and so if we go back and on the next page, we're going to say, what's going to happen. The ball is bouncing this way and you're moving that way. This is positive and that's negative. You want to remember that. So the first thing again is we get the initial momentum of the system. And that initial momentum, we're just going to call it PI. If you go back, you could see that the initial momentum of the system is a combination of PBI and PAI. So that's PBI plus PAI. Remember, the initial velocity, your initial velocity VAI was 0 meters per second. And so that means this part will just be 0 meters per second. And so the total initial momentum will be the same as the momentum of the ball itself, which is 0.6 kilograms times 10 meters per second. Okay. Well, we don't have to compute all that right now. We're more interested in the final momentum of the system when things bounce off. This time we have the final momentum of the ball in the opposite direction, and that's gonna be negative because you have a negative velocity. So negative mass of ball times the final velocity of the ball. And then also we have your own final velocity that stays as positive because you're moving in the opposite direction. So the total final momentum is negative mb vb final plus ma va final. And by the law of conservation of momentum, law of conservation of momentum, we get to see that the final momentum equals to the initial momentum. And the final momentum happens to be a combination of these two. So P BF plus P AF equals to PI. But then PI is the same as PBI. PBI is just the momentum of the ball itself. Remember, the momentum of yourself is zero at the beginning. So if we go to the next page, we can simplify the problem by saying we have negative MB VB final, negative MB VB final, plus MA VA final equals to PB, MA V MB, sorry, MB. MB is the mass of the ball. So, we want to account for that. This is the mass of the ball. Don't forget the subscript. So this is mass of the ball, and also the initial velocity of the ball. Our goal at the beginning, if you go back, you see we want to find in part B, we're told that the final velocity of the ball is 8 meters per second in the opposite direction. If the ball hits you and bounces off your chest, so afterward it's moving horizontal in the opposite direction. So the ball is moving that way. That's how the ball is moving. And it's moving, so the final velocity of the ball is negative 8 meters per second. And so we want to find your speed. That's what we want to find. Simplifying this problem, you see that VA final, if we move stuff, we get MB VBI. This is going to move to the other side. It becomes positive MB VB final. All over your own mass. So the mass of the ball is 0.6 kilograms times the velocity of the ball, initial velocity of the ball, which is, if you can recall, was 10 meters per second, 10.0 meters per second, plus mass of ball, 0.6 kilograms. And then this has become positive. Initially it was negative because it was the opposite direction, but now it's positive. So we just put 8 meters per second there. And then all over the mass of yourself, which is 70 kilograms. Punch in, we plug in those numbers. We get 10 and 8, that's 18, times 0.6 divided by 70. And so we end up with 0. That's your own final velocity, happens to be 0.15 meters per second. Hope you enjoyed the problem. Feel free to send any questions or comments. And looking forward to the next video, and have a wonderful day. Okay, thanks. Bye.